Okay, all right, good evening everyone. So welcome back to another sessions of the data class, data analysis class, okay? So before we continue on our stuff, just remind you that we are at this topic right here. So we are at Basic Python Part 2. And if you haven't done so, or if you lose the file from last week, you should download this file. Okay, so the two files and then put into your folder and open VS Code and make it ready. Okay, so I'll give you a couple minutes to do that. And in the meantime, I would like to also advertise very useful, very interesting and useful activity. So I think some of you that register for the 193 class will probably see this announcement. But maybe some of you haven't, so let me just put that up. Okay, so this is from Ajahn Nöy, which she had a pretty fun activity if you guys are interested in meeting new people and improving your design thinking skill, which is quite a useful skill for the 21st century. Okay, if you want to create like new stuff, solving like engineering or everyday life problem, then the design thinking skill is pretty useful. So if you are interested, there is the events called the International Student Discussion Sessions, and in this one we are going to collaborate with people from England. So you gotta meet new people and then try out your English skill too. Okay, so it will be a good experience for you guys. All right, so this one is gonna be on the 25th of this month, okay, and it's going to be during the evening time. So this is going to be the online activity. You go into the I guess the Zoom meeting, and then you form a group, and then you do some group activities with the people from overseas, which is really exciting if you are into getting new experiences, okay. And Ajahn Nöy told me that if you, participate in this event, then you get the certificate of participation too. So that kind of build your portfolio. There's like a new, new activities you can show it off to your, future employers, okay? And also as the bonus, if any of you participate in this event, I will count as another B-type event. So in case you wanna, maybe if you are missing the type A events, I was telling you that you could use the type B event as the substitutes, right? But as it turns out that actually B1 and B2, it's kind of not as fun, right? So I'm suggesting that if in case you wanna kind of as a backup, if you join this one, then you can claim this one as the B2 events, and then you don't have to worry about the completing all the A-type events too. Okay, so I invite everyone to join. Okay, if you want to join, please contact Ajahn Nöy. So this particular email, just email her. She will be thrilled to have you guys join. Okay, so please consider this event. All right, and back to our stuff. Okay, just want to make sure if you have problem running the this file, okay, just let me know before I begin. If you need my help, I'd be happy to help. Okay, everybody is ready. Okay, let's go. Okay, and I guess you might remember from the factory visit last time, right? I guess the speaker was mentioning using Python as the skill for the new recruit, so I think this one will be good for you too. So I didn't know that they actually required or recommended the new hire to have Python skill too. So that's kind of interesting. Okay, all right. So right now we're in Panda, which is as I mentioned last time, it's the crux of our class here. So Panda is the premier tool for data processing, data visualization, and things like that. So very, very useful to know, and I never regret my decision to learn it, okay? All right, so I think we went through some of these exercises of creating the data frame, which I mentioned data frame is like the Excel sheet, right? And then you also have the series, which is the column. And then we went through different methods of selecting the data, okay? Which, I mean, for those who just begin, it does take some getting used to. So I hope that you will have more practice, you know, with the homework, with the exercise from now on, okay? So, but so far we have used only a very small set of data, which, you know, the data that we worked on last time, you know, Panda is way too overkill, okay? But something like this would be, you know, a better candidate for using Panda for the analysis, okay? So first of all, you need to run the top box first in order to load the library, okay? So let me just do that. So I'm going to choose the Python environments, which is the one that I want right here. Okay, so you got to run the first code block first, okay? And then once you run the first one, then you can kind of skip down to the one that I'm talking about, which is this part right here, IMDb movie datasets, okay? All right, so if you download everything, then you should have all the files you need. You should be able to run this particular code blocks, okay? And this particular code blocks, you can see that this one is reading, okay? So it's reading the CSV file. So this file is actually in your folder, okay? You already had it in your folder. So if you can run this successfully, then that's great. If you cannot run it, can you let me know before I move on? Because we're going to be using this a lot today. So just make sure that you can run this particular blocks, okay? If you use your own laptop, that should be no problem. Or if you use the computer or run locally, that should be no problem. If you're running on Google Colab, you should let me know, because there are some extra steps that you need to know before you do this. Okay, so I assume that everyone running things locally, you should be able to run this cell, okay? All right, so let's take a look at what are we working on right now, okay? So if you take a look into your Data Explorer, you're gonna see that there is actually the file with this name, which is .csv. So this is a text file that contains the data. Shall we take a look? Yes, we can. And as you can see that it's just you know, a simple text file basically. And the columns are separated by comma, you know, all this comma. That's why it's called CSV, the comma separated value files, okay? You know what? And we can open this file in Excel too if you want to take a look in terms of like the spreadsheet, right? So I'm going to open files in Explorers, okay? And then I'm going to double click this one. And you know, Excel should be able to read this like this, okay? So you don't need to do this, but if you want, you're welcome to, okay? So just kind of skim through the file. So I guess this is the database for the movie, okay? So this movie, this database is rather old. As you can see that the year is like almost 10 years ago, right? All the movies are pretty old, but that's no point, right? I mean, it's no problem in here, right? And one of the things that you can see is that right now we start to have more columns. So if I start to have, you know, scroll down, like scroll to the right, you know, quite a bit, right? So this one, you know, Panda should be more useful. And also if you scroll down, you can see that we have a lot of rows in here. We have about 1,000 rows. So, you know, 1,000 rows is not too bad to use Excel, but, you know, when you have even more than this, then, you know, might be kind of cumbersome to work with Excel if your data is getting larger in terms of the row and the columns. But this one, I think it's a pretty good candidate for seeing how Pandas work, okay? All right, just one last time. If you have problem loading this file, you should let me know before we go. Okay, if there is no problem, then I'm gonna move on. Okay, so that means you can run this cell, okay, and you see something down below, all right? Okay, so let's go, okay. So first of all, if I were to just run this, right, and I displayed it, then yes, I can see a lot of things in here. which I guess that's a lot of things to look at, right? So maybe displaying everything is probably not a good idea. And you know, we usually don't display the whole thing per se, okay? So what can we do? The first thing is, if you want to just kind of see what the columns and row looks like, then maybe you only need a couple, couple top rows. Then this is a good way to do. So we're going to say the name of the data frame, which is movies, right? I'm going to say movies.head. Okay. Again, movie is like an object, right? And if you dot, you're going to access the function that you can use within this object. The one that we want is called head, and then you need to call this function. And if you run this, you can see that right now I'm only printing the first 5 rows from this data frame. So normally you do this in order to look at the columns, right, and look at some of the data in here. Okay. Next up, sometimes, you know, the top row is fine, but, you know, you want to see the bottom rows, and, you know, Panda has methods just for that. So I'm going to say movies.tail. Okay, so instead, the opposite of head is tail. So if I run this, then I can inspect the last 5 rows in this. Okay. Sometimes it is particularly useful if you have the spreadsheet that has the bottom row to be like a total. And sometimes the total row is quite problematic because it's not the data, right? It's the aggregates of the data. And sometimes you want to check if you need to remove the last row or not. Okay? Something like that. Okay? And just to add, you know, just a little even more tricks is I can even input a number in this head and tail function. For example, if I put number 3 in here, that means that I only need to look at the first 3 rows. Okay? And also, if I put 3s in here, then I only need to look at the last 3 rows. Okay? So that's kind of little neat tricks in here. Okay? Okay, so next up, okay, I just want to see some information about this data frame, and Panda has the methods for that. It's called info. So I'm going to say movies.info. Okay? All right, and this is useful because I can see some of the things that are quite important in data processing, which is right now it's saying that I have 1,000 entries. Okay, so 1,000 entry meaning that this particular data frame has 1,000 rows. Okay, but then if I look at some of these columns, so this is the name of the columns, right? And I can see right away that there are 1,000 non-null. So that means that in this particular columns, okay, there are 1,000 data points in data is in here, which means that the data is not missing in these columns because you have 1,000 rows and you have 1,000 data, which is good. Non-null meaning it not empty. Okay, and you can even see that there is the data types in here. Okay, so if you kind of look around, look from top to bottom, you're going to see that most of the column, you know, is not missing any data because they all have 1,000 non-null data, right? But as you can see right away that there are certain columns that has, you know, less than 1,000 data, right? So this is the column that has missing values, okay? And, you know, you can kind of see it in Excel too if you want, right? So I'm going to go back to my spreadsheet in Excel. And the last 2 columns, they do have, you know, missing data, right? So, so usually in data processing, if we have missing data, I think we should do something about it because it's gonna be a problem later on if you don't deal with the missing data, okay? And sometimes if you just have to look like, if you have to scroll to the data like this, you can miss it. But if you use panda.info, then you can inspect right away that, okay, maybe we need to do something about it, right? Treating the, making sure that the missing data is taken care of, okay? We'll do that later, but right now I'm not going to do anything, but just be aware that you have some missing data, okay? And another thing is, if you just want to take a look at the number of rows and columns, then there is an even easier method, which is movies.shape. Okay, so movie.shape just tells you how many rows and how many columns in your data frame. So 1,000 row and 11 columns. Okay, very simple as that. But it doesn't tell you which column, like what name it is, or if it's like what data type and things like that, that you need info function for that, okay? And also, if you just want to list the columns, you know, the name of the columns, then you can do movies.columns with the S, okay? And as you can see that some of this is not coded in yellow, so that means this is not the function. This is the attributes or the data that belongs to this particular object, okay? And right away, I can see, I can get the name of the columns. And this can be useful in many, many cases where you need to format or you need to manipulate the data, the column names, as we will see very, very soon, okay? All right, so first of all, let's do some basic data manipulation like renaming the columns, right? If you want to rename things in Excel, you know, why don't we can just rename it, right? But that's also dangerous because you already changed the data. So what I like about Panda is we never change the data, but we do data processing in this file, okay? So I'm going to say movie.rename. Okay? So rename is also a method that you can use on this object, okay? And inside there are many arguments that you can put in. One that is relevant to this context is columns, okay? Columns going to be equal to dictionary, okay? So this curly braces is the dictionary, right? Inside the dictionary, you're going to put in the key and value pairs, okay? And in here, you're going to input the original name, which is runtime. So there is a column called runtime, which is minutes, okay? Okay, you have to type this exactly, because if you don't type it exactly, it's not going to know which column it should change, okay? And then I'm going to just make sure that it doesn't have the parentheses, because I hate typing parentheses. So I'm going to say run time minutes, okay? Okay, so if you can you make sure that you type it in exactly like I do, because later on when I use this column, then I'm going to use this exact spelling, okay? And there's another column called revenue, okay? And it's going to be in millions, okay? I want to change that into revenue millions, okay, like that. Okay, just make sure that, okay, so the spelling is right. Okay, so right away, if I were to run this, okay, so keep in mind that I have not typed everything that I had in my solution yet. Okay, I'm leaving out something intentionally. Okay, but let's see if I were to run this, what's going to happen. Okay, I run it, and then if I scroll through the left, which is I want to check out the column's name. You can kind of see that right now the column names actually changed. So before it has the parentheses, right now it doesn't have parentheses anymore. So, which I mean seems like it's doing its job, right? But check out this behavior. Okay, so let me make a new blocks in here, and let me just type movie. Okay, one more time. So keep in mind that this one is after we had the rename process, right? So I'm going to type in movies and check out the name of the columns one more time. You're going to see that right now the column name is actually back into the one with the parentheses, okay? And you might be wondering, why are we seeing the old data, you know, although we already rename it, okay? And the reason, and this behavior is quite important, right? So when you perform this particular function right here, this function or this process does not modify the original data, you know. What you are seeing right here is actually the new copy of your data, okay? So it would be something, it would be the change to your data. I mean, I guess it would be like a preview of what would it have been if you were to replace it, okay? So So this, what you're seeing right here is not the original data that got changed. This is just a preview, okay? So if you want this operation to modify the original data, you have to explicitly say in the function, okay? Because Panda is very, very particular about when would you want to rewrite your data, because that's important, okay? So if I want to rewrite it, I have to tell it explicitly in place equal true, okay? So with this particular argument, it's going to replace our original data with the new column name, okay? And you have to be explicit because Panda is very careful about modifying the data, okay? And as I was telling you, right, you don't want to modify your data accidentally because that's going to cause problem later on. So you want to be very particular about what you are going when you are going to replace your data, okay? So if I have this option on like this, and I run this one, okay? Then if I go down to another block where I just want to check out what it is, which is right here, then you can see that now my data or my columns has now changed, which is good, okay? So I want to be explicit about modifying my original data, okay? And just for the extra tips, another way that you can do is actually do this too. If you don't like the syntax in place equal to true, which for me I don't like too, I can do this. Okay, so let me show you. This one also valid, so I don't have to have in place equal to true here, but I can say that movie equal movie, okay? And if I do assignment like this, it also means that whatever getting preview, which is the new column's name, then it will get rewritten into my original variable. So that's another way of making sure that the data is changed, okay? And for me, I actually prefer this syntax because when I see equal sign, it makes a lot of sense that I'm going to assign new things into my old variable. Okay, so I do like this one more than the in-place syntax, okay? So I'm going to keep both for you guys here, okay? Okay. Okay, so we just, so far we just modify, a couple columns, right? But what if we want to modify a lot of columns at the same time? Can we do that? Of course we can, okay? We can do this too, okay? So this is the one that maybe I want all the columns name to be in lowercase, okay? So I'm just naming the new columns, everything to be in lowercase, but I have to make sure that they are in the exact order too, okay? So this one in the exact order, okay? So, and all I need to do is just saying that I want my movies.column to be equal to new column name, which is the list in here, okay? So if you want to change everything, then you can just reset the attribute columns to be the list with the new names in it. You can also do that too. Okay, okay, and let's check it out, shall we? So I'm gonna display. I'm gonna say movie.head because I don't want to see a lot of rows. I just want to see a couple rows, just to check my columns. Okay. So if I run this, you can see that all of my column names are in lowercase, which is good, right? This is very easy to type. Okay. And you know what? This is fine and good, right? But what happens if you have a lot of columns and you want to apply this operation in all the columns, and you don't want to type this out? Actually, if you're getting better in Python and programming, then you can kind of write something like this. Okay, so I'm not going to go into much details in this, but in a way, you can write like a little script, a program that actually go through the name of the column one by one, but using a for loop, right? So this way, if I do something like this, I don't need to hand typing the name of the column by manually, but whatever the column it has, it's going to make sure that it gets into the lowercase. So this is something that you can do if you are getting better, and you can automate yourself a little bit more. So you can run this one too. It's not going to have any effects because all the columns are already in lowercase. Okay, so just want to let you know that there always going to be, I guess, the way to eliminate the manual work in Python. Okay, if you are getting better at programming. Okay. Okay. So right now I'm just rename all the columns into lowercase. Okay. And if you're getting even better in another level, you can make your code into even more concise form. Okay. So in this manner, you have to use the for loop, right? But if you're getting better, then you actually don't need to use any for loop. So this one is called list comprehension. It's a way to write a for loop in one line, basically. Okay, and I'll just leave it like this because I'm not going to test you on this. But I just want you to know that the more you're getting better in Python, then the less code you're going to write to achieve the same thing. Okay, so this is just one line to make all the columns into lowercase. Okay. So you can run this too. It's not going to do anything because your column is already in lowercase. Okay. Okay. So far so good. We already have columns in lowercase. So what else do you want to do? Okay. So usually if you have column with numbers, you might want to see the basic statistics on all the data. Okay. And Python has a super useful way of doing it. So movies.describe right here. Okay. So describe is very, very useful, as you can see here. Okay. So basically what describe does is it's going to take all the column with numerics data and then give you the basic statistics like count, mean, standard deviation, mean, and then all the percentiles, okay, and the max and min, things like that. Which, I mean, sometimes you just want to see all of this, right? And then if you have to go back and calculate each column, it's kind of tedious. So this function or method is very useful. You just want to see all of these statistics in the numerics column, okay? I use this a lot when I do grading, student grades, because I just want to see like min, max, and mean, right? And I just use describe, and then it's all done, okay? Okay, and again, I can also do specific, basic statistic on particular column. If I need to choose one column, okay, this is a series like I was telling you last time. If I were to write movies, right, and then I want to see just one column, right? So let's pick like rank in here. I can do that, right? And keep in mind that if I were to do this, it is almost as if I'm selecting just one column in the spreadsheet, okay? Let me just show you this. See, it's just one column, right? Although what you're getting is actually also the index too, which is the name of the movie, okay? But I can also run describe with just one column too. Okay, if all you need is just the statistic of just one column, you can certainly just select one column and run the basic stats on that too, okay? Okay, so and another way that you can do is if you want to select more than one, but you don't need to select everything, then you can even do this. So I'm going to choose rank, right? And then I'm going to choose another column name that is numerics. So let's see year. Okay, I don't know why, but why not, right? So again, if I were to do this, it would be as if I were to select two columns, which is rank and year in Excel, right? And I want to run describe function on it. Then I will only see the stats for these two columns. So that's another thing. If you have a lot of columns and you only need two, then yeah, you can select just two. Okay, I use this a lot, okay, just for the initial exploratory of your data, okay. And okay, another thing that's super useful is to inquire the unique value, okay. So sometimes in your column you might have the text, right? And maybe it's a good, just a good way of looking at your data. For example, I have a column name, genre, right here. Where is it? Okay, right here. So this one is not numerics, right? It has text in it, but it's a type of movie, right? And I want to see kind of what is the distribution of the movie type in my data. I can do that right away, very, very easy. Okay, so I'm going to use the value count function. Okay, let me show you this. I'm going to say movie. Okay, movies, right? And then let's see genre. Okay, and then dot value counts. Okay. Okay, sorry. First thing, I want to say unique first. Okay, because in my solution I have unique first. Okay, so let me use that. So unique will give you the unique list of things in your genre. For example, something like this, right? Which, I mean, you will have a lot of things in here, but this one might be useful in certain cases where you want to loop through like a unique type of your data, your movie genre. But what I find very, very, very good at exploring your data is a function called value count. This is super useful. Okay, so let me show you this. Genre, and then I'm going to say value counts. Okay, and this one I really like because now I will get the number of things that are repeated too. So I can see right away that in my database I have 50 movie that is in this type, and so on with less frequencies. Okay, and again you can use this data for something else, for plotting, for like exporting into other things too. But right off the bat, this is very, 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 very easy to do. Okay. And if I want to go even further, if I want to just see like the top 10 movie genre in my database, I can change the operation called hate. Okay. So movies genre, right? Dot value count, because value count will return the series. Okay. And from the series, I can also chain another method called head. Okay. And inside I want 10. Okay, so if I do this, then it's going to show me the 10 most frequent movie genre in my database, which is something like this. Okay, so that's pretty cool, right? And if you want to see even further, I can also do tail too, because tail will work with series, but it will give you the last 10, which I don't have many in my, I don't have much in my database. Okay. Okay, something like this, very useful. Okay. Okay, so now it will be slicing time. Okay, so like last time. Okay, if I want to inspect, specific column, I can say movies. Okay, what do I have in here? I have genre and rating. Okay, and rating. Okay, you have seen this particular syntax already. So this one is selecting the columns of your spreadsheet. Okay, so the genre and the rating columns. Okay, and again, the index also come with it. Okay, so the index is the name of the movie. So even though we only select 2 columns, we already have the row index with us for further slicing if you want. Okay, so this one I use very often. Okay, and also if you want to do the row, then you can do the .log. Okay, for example, I can do movies.log. Okay, and in here I can just type in the index. Okay, and this is where your index, row index things in Panda is particularly useful, because I already set my row index to be the name of the movie, right? So if I want to select particular movie, all I need to do is just type the name of the movie, because it's the row index. Okay, so in here I can just say I want to see the detail of this movie, Prometheus. Okay, and I can do that too. Okay, and it tells me all of the column, all of the information from the rest of the columns. Okay, And again, this is something that I like a lot when I work with big data, because instead of, if I were to use Excel, I have to use like A1, which doesn't mean anything. But if I have my index to be something that I know has meaning, then if I see code like this, I know what I'm I know what I'm getting, right? I want to see the details of this particular movies, right? And this is what you got. Okay, again, this is the row information, but it just lists as the column because this is like a series. It's a one-dimensional data. Okay. Okay. And again, you can also using ilog, which is the numeric in a sequence too, if you want. So if you want to do the sequence, you can do it. Okay. So movies.ilog, and then if I were to do 0, that would be getting the detail of the first movie. Okay. There you go. This one is going to be Guardian of the Galaxy. Okay, so the index is going to be listed as a name, right? And then if I do ilog of 1, then that will be getting the second movie, so second row. So that will be Prometheus, something like that too. Okay, so you can use both the index, the row index, or the numerics index too if you want. Okay, so that's very, very useful. Okay. Okay, and again, I don't even need to stop at this, right? I can even inspect specific row with like a lot of row at the same time. So maybe I want to see 0 to 4. So that's going to give me the first 4 rows, something like that too. Okay, I can also do that. Okay, so let me just do movies.ilog of 1, or I can do from 0 to 4, or something like that. Okay. Okay, so far so good. I think you have seen this from last time too, okay? But the next one is going to be new. Okay, so this one is filtering data frame, okay? So filtering is particularly useful if you start to kind of, you want to get a certain type of data based on some conditions, okay? So let's do this. Tonight we're going to pick a movie to watch, okay? And I only want to pick the movie that is directed by Ridley Scott, okay? That guy, has a lot of movie in his belt, right? How do I filter something like this in Panda, okay? So first of all, I need to use a logical operator, okay? If you recall from way back before midterm, I was saying that if I were to do this, 1 equal 1, right? This particular syntax is the questions, right? And if it's the questions, then I will get true or false as the answer, okay? So let me run this. I get true, okay? So this particular thing is called the logical operator. It's the questions that you want to ask Python, okay? I want to do the same thing. I want to ask the question, which movie is directed by Ridley Scott, okay? So I'm going to do this, something like this. Movie, and then I'm going to say director. Okay, director. Okay. This particular syntax is selecting all the columns in the director columns. Okay, so sorry, select all the data in the director's column. Okay, if I were to run this, this one will give me the data in the director columns. You can refer back to the data if you want, right? But this one tells you which which row, like which movie has which director. And again, if we already have the name of the movie as the index, we already have both, which is quite useful, okay? But what I want to do is I want to ask Python if this is equal to Ridley Scott or not. Okay, I want you to think about this one for a second, because you know what? When I was writing 1 equal 1, that's just one question, and I get true, right? Which is straightforward. But right now, if I were to type movies and then with the director, it gives me a lot of movie, right? Because we have 1,000 rows. So I have 1,000 names in here. If I were to ask Python, like which one equal to Ridley Scott, I should not have just one answer back. I should have 1,000 answers back. Okay? Because I'm asking a lot of questions. This one is like I'm asking 1,000 questions in here. Okay? So if I were to run this, you will see what I mean. Okay? I'm going to run this for you, and here's the thing, right? This is 1,000 answer. Okay? And again, I already have my indices, which is the movie name. And this is the answer, whether that movie is directed by Ridley Scott or not. Okay? And once I have this answer, Panda has a very cool trick, which is you can use this answer to filter the rows. Okay? And to do that, all you need to do is to put this one in a variable. So I would say field, which is filter. Okay? So this is like a variable that contains 1,000 answer. Okay? And I'm going to put the answer in the movie itself, like this. Okay? I can do that. Okay? And you're going to see right away that what I got is, how about a couple movies in here, right? But let's go into the director. Oh, actually it's here. Okay, you're going to see that all the director is Ridley Scott. Okay, that's pretty cool. Got it? Okay. And the way or the operation that I'm doing right here is called Boolean indexing. Okay, Boolean indexing. Okay. Okay, so Boolean indexing is like this. If you have true and false, right, Panda will only give you the row with the true answer. It's called Boolean indexing. Okay. Okay. It's a quite kind of moderate concept in Python. Actually, you know what? I'm going to show you the Boolean indexing in a more, I guess, more primitive form. Okay. So let me show you this one. Okay. I'm going to import NumPy as NP. So NumPy, it's like a scientific calculation library, right, that I mentioned last time. Okay. It's not important here, okay? But I'm going to do this. I'm going to say A equal np.array, and inside I'm going to have 1, 2, 3, 4. Okay, and then I'm going to print A for you. Okay. So just for all intents and purposes, you only need to know that I have a list of numbers in here. Okay. I'm going to do this. If I were to do this, B equal, okay, another list, right? This one equal true, false, true, false. Okay. Okay. Notice that B and A has the same length. Okay, it has 4 things in it, right? I can even print B for you if you want, but it's very unnecessary. Okay. I'm going to do something like this. I'm going to say A, but then I'm going to do B inside. See what I do? See what I did here? Okay, let me just format myself. So what I'm doing is that, you know, if I put the Boolean inside the A, then it's only going to select the location, the data associating with true. Okay, so if it is true, the first data is true, so it's going to select 1, right? But the false, you're not going to select it, so you're not going to have this one. If it's true on the third element, then you're going to get 3. And if it's false on the fourth element, you're not going to get 4. So with this particular way of writing, I'm going to get 1 and 3. So let's check it out, 1 and 3. Okay, again, this is also Boolean indexing. Okay, but in a more primitive form, okay, in NumPy. So Panda can also do the same thing. If you give Panda the list of Booleans equal to the number of row, it's only going to show you the row associating with true. Okay? So that's why we're going to use this for filtering. Okay. All right. So why don't we, pick other movies? Why don't we pick the movie that's directed by James Gunn? Shall we? You want to see what's inside your database? James Gunn. Okay, we can do that too. So all I need to do is to change this one to James Gunn. I hope that's the right spelling. So let's see what's right. So yeah, I mean this database is pretty old. So right now this Guardian Galaxy 3, it's like Superman and all this kind of movie. But as of this database, then yeah, he only has the Guardian of the Galaxy and other movie which I have not seen it, something like that. Okay. Okay, if you kind of explore into other people's code, okay, some people might not write it like this. If you want to be super concise, then also you can do something like this. I can just write movie, right? And then I'm going to put all of this inside my, like this. Okay, so that would be another way of doing, which is achieving the same thing. Although I don't like this kind of syntax because it's too long. Okay, I like to separate the filter out into the first line and then using it to filter later. So that's my style. Okay, so I'll leave this one for you, but I don't like it like I don't write it like this very often. Okay. Okay, so let's do something even more fun. Okay, so you know what? I like a movie by Ridley Scott, but I only need a good movie, so the rating needs to be high. Okay, so we're gonna have two conditions now. Okay, so first I'm gonna write filter number 1. Okay, it's gonna be movie, right? And then director. I need the director to be equal to Ridley Scott. Okay. But that's not enough. If I want to choose the movie for tonight, I want good ones. So I'm going to say filter number 2 equal movies. But then the rating needs to be higher or equal to 8.6. Okay, so that is two things that needs to be true. Okay. And again, if I inspect this filter a little bit just to show you, I can do this, right? I can print filter 1. Or I should say display might be a better way to do. Okay. Oh, what happened here? Director, not directory. Okay. Here. So again, if I were to inspect my filter 1, you can see that this is the answer, right? The answer to the first questions. But then I can also have the second answer to the second question, right? Okay, but to me, you know what? I need both answer to be true. So what I can do is I can combine both of them with the and. Right? So if I do filter 1 and filter 2, what I'm going to get, it's actually the combination of both. So anything that is true, it has to be true in both conditions. If either one is false, then you're going to get false, which is good when we want to make sure that both condition is satisfied, right? So this is how we do it. We want to use the combination of both. So and or is something that you can use later. Okay. All right. So let's just do this in our movie, shall we? So we're gonna say movies, right? And then I'm gonna say field 1 and field 2, and that's it. You're done. And let's see, which movie shall we watch tonight? Actually none. Why? Because I misspelled? Not really. Rating. Actually, I don't know. Maybe my rating is too high. Maybe I lower the rating a little bit, 8. Yeah, oh, okay, so definitely my rating is too high. Okay, so I didn't get, so if I lower the rating a little bit, then I can see that actually The Martian, it's the best movie. I mean, according to this database. Right now he has more stuff, right? So I don't know, right? But Martian would be my go-to, I guess, go-to examples, right? So Yeah, you can find something more if you want, like Christopher Nolan, something here. So you want to see his best movies? You can write something like Christopher Nolan. I hope I make this spelling correctly. Okay, and Interstellar is a pretty good movie, right? The Dark Knight, definitely a good one to watch. Although right now, you probably have something else, a lot more. Okay, too. Okay. Another thing that I like is also this particular function called isIn. Okay, I use this one quite often, so I'm introducing it now. Okay, so also, in addition to writing like logical operator, there is also a certain method that also return the answers, true or false. Okay, for example, I can say that movies director, okay, dot isIn. Okay, so isIn is the methods, okay, that apply onto this columns. Okay, and I can say that I want to check whether the director is in this list or not. So Christopher Nolan and Ridley Scott. Okay, so let's check two directors in here. So this one is quite useful. For example, like I use this a lot, like student is in particular section. When I want to create student separate by different section, I say if the student is in that section, and I can filter out that student from the entire roster. Okay, so this one, and if I run this one, you're going to see that I also got, true or false again. Okay, and I can use this one as the filter, so Boolean index back into my data frame. Okay, so filter one more time, right? And then I'm going to say movies and then filter. Okay, and that will give me the list of movies directed by both directors. Okay, so far so good, right? Filtering like this you can do in Excel, but let's check out a more complex filtering condition, and you're going to see that Panda gives you a lot of power per se. Let's check this one. So I'm going to say I want movie between 2005 and 2010. Okay, the rating has to be 8, and the revenue has to be the lowest, 25%, 25th percentile. So again, I want to see the movie, the good movie that's not selling very well. So the movie that you should go watch because it hasn't made much money. Okay, so let's check that one out. So first, I want to say filter one. Okay, I have a lot of filter. Okay, I want to say that movies year has to be larger and equal to 2005. Okay. Filter 2, year has to be lower than 2010. Okay, so that will give me the year between 2005 and 2010 inclusive. Okay. Another filter is I want to say that movie rating has to be greater than 8.0. Okay. And the last filter is pretty cool. Check this one out. So I'm going to say that movies, okay, revenue millions, okay, it has to be lower than movie revenue millions, okay, dot quartile, okay, and then you do 0.25. Quantile, not quartile, quantile, okay. Okay, so you haven't seen this thing before, but again, you can, if you from the name, you might have guessed that this one should return you like a number of the fourth quartile threshold. Okay, so I want to get the movie that it's a good movie but hasn't sold very well. Okay, and as you can see that if you have more complex logics, right, the code looks the same. You can have more filter, like as many filter as you want, right? And it's clear what it is. And in the end, you just need to plug all of this into your data frame as a Boolean index, okay? So I'm going to say movies, and then filter 1, and filter 2, and, okay, and filter 2, and filter 3, and filter 4, okay? I don't think that in Excel you can do this very easily anymore. But this one, it looks the same, like the pattern is the same. No matter how complex your logics are, it looks the same. That's kind of the beauty of this kind of approach, okay? And I can run it, and maybe today I want to go back and check out 3 idiots. I don't know what this is, okay? Something like that. Okay? Okay, bear with me. One more concept and we get a break, okay? Bear with me, okay? So lastly, you know, it's very, very common for you to create a new column, you know, based on some formula, okay? So let me show you this. If I want to do this in Excel, let me just copy this one, put it in here, and then I'll just run it, okay? So something that I want to do is I want to group the movie based on the rating, okay? So if it's good or bad, okay? So if I do this, I want to have another column called, what's it called? Rating category, okay? So something like this, okay? And this one will be based on the rating columns in here, okay? So I can do the equal sign, right? If, okay? Okay, so if the rating, so this one right here, okay, is greater than 8, right? I wanna categorize it as good, okay? But if not, it's gonna be bad, okay? Like that. You have done this before, I'm sure, right? Excel, and then you can just kind of apply this function into all of the column of the rows, right? I want to do the same thing like this in Panda, okay? I can do that too, of course. But it looks a little different and might get, you know, might take some time to wrap your head around this concept, okay? But when you need to have formula, okay, in Python, it's a function. Okay, so first you define what function you want to have. So that's going to be def, okay? So you start with the function, okay? And you can name it anything. I'm going to name it rating function. Okay, like this, okay? And this function is going to be special because you already know that what you want to apply this function to, it's like a formula, right? The formula apply to the rating columns, okay? So in this function, I want to get the argument, right? And that argument should be the rating, okay? So I anticipate that the things that comes into my function is going to be the rating, okay? So I'm going to type ratings in here. Okay, so this one, I design it so I can do whatever I want, okay? Yeah. And then if I have the rating, then I want to create the condition, right? So if rating is larger than 8, okay, I want to return good. Else, I want to return bad, okay? As you can imagine that this particular function, it's exactly the same. Sorry, let me just do this for you, okay? It's exactly the same as this one right here. Like this thing in here, it's like this one, same thing. It's the same thing that you would write in Excel, formula, okay? And you can make a case that in this particular case, example, writing in Excel is shorter, right? I mean, I have to use 5 lines of code instead of just 1 line in here. And I agree, okay? In this situation, writing in Excel is better. I mean, I guess it's more concise, okay? But you see my point later on, okay? Okay, so once I have this, this formula or function, I have to kind of apply it into this rating, right? Because in Excel, I explicitly said that I want this I2 in here, right? This I2 is like a rating function, right? So a rating columns, right? So I need to apply it to the rating columns. Okay, in order to do that, I want to do this. Movies dot rate movies, and then I want to pick the rating. Okay, so I'm selecting the rating columns, right? And I want to apply. What do I want to apply? I want to apply this function in it. Okay? And if I were to run this, you're going to see that I have good and bad. Okay? I don't think you have seen this before. This is kind of intermediate to advanced concept. Okay? So there are times, like I always tell you, right, if you have function, right, if you want to use your function, you need to have parentheses, right? But this is the time, one of the few times when I will tell you that you don't need the parentheses, okay? This is different from if you were to write something like this, okay? So notice the difference, right? If I write something like this, it does not work. I think it will just yell at me. Yeah, it's just going to yell at me, okay? In order for this to work, you cannot have the parentheses. You only need the name of the function, which is totally weird, right? Like, why would you give it the name of the function and not have the parentheses? Like, you're not calling it, right? This is the time where I should tell you that this apply thing is called the higher order function, okay? Okay, so apply, right? It's apply, right? It's called the higher order function, okay? This fancy name tells me that when you want to use apply, it needs the function, but it doesn't need the function to be called, okay? It just needs the name of the function only. So it is a function that takes the function as an argument. So it's a function that needs function. So that's why it's called higher order function, okay? So you give it a function like this. You haven't called it yet, right? What this apply is going to do is it's going to apply this function to all the data in the rating columns. Okay, so one by one, start from the first data until the 1,000th data. It's going to apply that particular function into that data, meaning that it's going to feed in the rating, from the first row to the last row into this argument right here, okay? And what you're returning is actually, we're returning the text, okay? So this one will take some time to wrap your head in. But, and we will revisit this topic later on, okay? But I just want to kind of prelude to this, that this particular thing, like the whole thing in here, is the same as doing this one, the same thing, okay? Just want to kind of set the stage for the, I guess, a more in-depth topic later on. But this is how you would kind of apply a formula to the column, like what you would do in Excel, okay? All right, so right now I already have the results, right? So all I need to do, what's left is actually to create the new function, a new column, right? So I'm going to say movies, okay? And now I want to give it a new name, new column name called rating category, okay? And then it's going to set it equal to whatever this thing gives me, which is good and bad, right? And then let me see, movies dot head. Oh, okay, I have extra. Okay, and if I run it, And you're going to see that I have the new column, which has the result from that formula. Okay? Okay. And again, if you think that this one looks way too complicated, I agree. For something simple like this, this is kind of overkill. But you're going to see that there are times when we need complex logic. And this pattern is actually very, very useful for something that's much, much complex than this. It's going to look it's always going to look like this, no matter how difficult your logic is going to be. Okay? It's going to look like this, and you will see later on. Okay? Okay? And just one very, very last thing. Okay? If you start to get even more advanced in Python, you can even write like all of this logic in just one line. Check this one out. This one, it's actually the same thing as what I was doing before. Oh, okay, actually I have this one, okay. So notice that this is the same thing as what I was doing in here, but just one line instead of like 7 lines. So this one is an advanced way of doing. It's called the lambda function. Okay, so you don't need to know this one yet. Okay, wait until you're more comfortable with other concepts first before you come back to here. But there's always going to be a way for you to write shorter things. Okay, but this one, let's hold on to this for now. Okay. All right. Thank you for staying with me. We'll just get like 10 minutes break. Okay, and come back for the rest of the class. Okay.